Okay, we're going to go over the second side of the worksheet from section 1.1 that we worked through the front side on in class on Friday. And the three problems on the back side, as I said in class, are exactly the same questions that were on the front side, but on the back they're asked graphically instead of with tables of numbers. And it's important to be able to go back and forth between these things because it's not that unusual in life to have information about a relationship only described graphically. So, for example, in this problem, they give us a function f of x, and now this is the graph of this function. And see, it looks like a straight line. It's got a little hole in it right there. And the question says, as x approaches 1, what's the limit of f of x as x approaches 1? So if you remember, this means to write more slowly. What is f of x getting near as x nears 1? And so we'd use our arrow notation for x gets close to 1. And so that's the question. On the other side, we answered that by taking various values of x near 1 and plugging them into f of x and finding what those values were and then making a judgment about what it was nearing. But remember, f of x represents the y coordinates so whatever you put into the function, whatever this number is, that's an x coordinate, and then f of x is that y coordinate. And so when we say x is getting close to 1, I can visualize that. Here's 1 along the x direction. And so as the x's are getting close to 1, moving along here, either from below or from above, as the x coordinates are getting close to this magic value of 1, the question is, what are the y coordinates on the graph getting close to? And so if we follow it, we can see that what do I want to do here? Well, I thought I was going to change colors, but we'll see if I can do it. So as the x coordinates are getting close to 1, the y coordinates along the graph are getting closer and closer to this black dot. And the y coordinate of that black dot is 4. So if we just think about this sentence, what is f of x nearing as x nears 1, and instead of f of x we write the y coordinate of the graph, then it's easy to see that the answer to this should be 4. And it doesn't matter whether you're getting close to 1 from the right side or from the left side, your y coordinates are getting close to 4 as the x coordinates are getting close to 1. And so if we adapt that point of view, then the second question, which asks about what happens as x nears 3, we can come back to the same picture and say, well, here's the value of x that's 3. As the x's get close to 3, again, from either below or above, as the x's are getting close to 3, the y coordinates are getting close to, well, the points are on the curve are getting close to this hole in the graph. And the y coordinate of that hole is 6. And so it looks like whether your x's are getting close to 3 from the right side or the left side, the y coordinate is getting close to 6 as x nears 3. And then finally, our piecewise graphs are a little bit weird looking because they can have jumps in them, and that's what happens here. Here we're asking about, again, x is getting near to 1, but when you get near 1, here's 1. When you get close to 1 from below, the y coordinates on the graph are going down towards this hole, which is at 0. But if your x-coordinates are getting close to 1 from this side, from the right side, now your points on the graph are getting close to this hole, which has a y-coordinate of 3. So your y-coordinates from the left side are getting close to a y-coordinate of 0, and from the right side are getting close to a y-coordinate of 3. But the main thing is that you realize that what we're doing is we're letting the x's get close to a target, and then on the graph we're seeing what value the y-coordinates are nearing. Say 3. And so this limit, we would say, does not exist as a single limit because the limit as x approaches 1 from the left side, this is the left side, the negative side. As you approach 1 this way, it looks like your y-coordinates are getting close to 0, and as you approach 1 from the right side, it looks like the y-coordinates are getting close to 3. So the fact that these are not equal to each other means that the limit doesn't exist. That didn't happen on the other two problems. In this problem, whether we were approaching an x-coordinate of 1 from the left or the right, we were still heading towards this same point with a y-coordinate of 4. And whether we were approaching 3 from the left or the right, we were still heading towards this hole that had a y-coordinate of 6. So in this case, we were able to answer the limit questions, and in this case, we would say the limit does not exist.